Hello, welcome to my channel. Here we are discussing the questions from the topic electricity for Edexcel IGCSE Physics examination. That too from the past 4 to 5 years of Edexcel board exam questions. In fact, this is the fourth video of this series and the link to the other 3 videos are given in the description box. Before we start, please like and share my videos and also subscribe to my channel. In fact, these videos are good for all exam boards because almost all exam boards cover the topic electricity and circuits. And I shall show you how to answer the questions. So let's start with the first question of this video, that is question number 19. The other 18 questions are included in the previous videos. So the question is, what is meant by the term electric current? So electric current is, as we know as a definition, it is a rate of flow of electric charges passing through a point. So let us put it as an answer. It is the rate of flow. We can include it as I equals dq over dt. Now the next part of the question is, the figure shows an electric circuit to test the fuse. This is a fuse given. Give a reason why an LED is included in the circuit. And we know LED is used as an indicator. So it indicates whether there is a current or not. So let us write the answer. The LED indicates whether a current is present or the fuse is still working. LED indicates there is a current present, or even or fuse still working. This is a symbol of an LED. The arrow shows that it is emitting light. The arrow indicates that it is emitting light. Add another component to the circuit in diagram 1 to measure the current in the fuse. So we can connect an ammeter. You know that is an instrument used to measure the current. The question is to measure the current. So we can connect an ammeter in series with the fuse. Ammeter in series with the fuse. We always connect ammeters in series. Now the next part of the question, it shows that a current of 0.6 ampere is starting from the battery or power supply, and it branches out as 3. There are 3 branches. The question is, calculate the current in I1. Calculate the current in I1. As you see here, 0.6 ampere is branches out into 0.2, then I1, and then 0.3. Therefore, when you add these 3 branch currents, you have to get it as 0.6. Okay, so we know that 0.6, it is the sum of 0.2 plus I1 plus 0.3. Therefore, I1. 0.6 minus 0.5, this will give an answer of 0.1 ampere. So let us put it as an answer here. It is 0.1 ampere. State the current I2. State the current I2. So I2 is, this is the current I2. Please remember, if 0.6 ampere current is leaving from the cell or the battery, the same 0.6 ampere current must end up, whether it is branching into different branches or not. Finally, the same amount of current, if it is branching out, they have to get added up, and finally it should end up as the same current in the cell. So if 0.6 is starting from the cell, I2, the current that is ending up at the cell, is also 0.6. So the current will be 0.6 ampere. Explain which lamp is the brightest. And we know that the brightness is depending on the amount of current flowing through. So out of this, uh, lamp 3 has the highest current, and point 1 is, so I am writing the answer here. I1 is 0.1 ampere. So when you compare, lamp 3 has the highest current, therefore the brightest one is lamp 3. Explain which lamp is the brightest. Lamp 3 is the brightest. Lamp 3 is the brightest, as the highest current flowing through it. Highest current through it, flowing through it. Now the next part of the next question is, a student investigate how the current in a 60 ohm resistor varies with the voltage across the resistor. The student is supplied with these components. Draw a circuit diagram. So there is a battery, ammeter, voltmeter. So there is a battery. So we can say this is a battery, the symbol for battery here. And there is an ammeter. There is a voltmeter. The 60 ohm resistor. Variable resistor. Variable resistor has the symbols, a cross arrow like this, and there is a switch, then connection wires. So ring up the circuit. So let us draw the connect the ammeter in series. Then we have the 60 ohm resistor, fixed resistor. Then there is a switch provided. Then we have the variable resistor. And the voltmeter is connecting parallel to the 60 ohm resistor. This is the resistor 60 ohms. Now the question is, describe a suitable method a student could use for this investigation. Describe a suitable method for this investigation. So he is studying, or investigation is how the current varies with voltage. This is the investigation. So by using the variable resistor, he can vary or adjust different voltages across the resistor, and each time measuring the current. This is the way he can do the investigation. So let us put it as an answer. Since there is a switch here, the first step is, or the first thing what you have to do is close the switch. Okay, then let me write it as the first step. Adjust the variable resistor to get a suitable voltage across the resistor 60 ohm. Adjust get a small suitable voltage across 60 ohm resistor note it down, measure the corresponding current, then as a part of improving accuracy, do this current measurement for another 2 to 3 times and take the average. So let us include that also, measure the corresponding current, then measure current 2 to 3 times and find the average. This is step 1. Now as step 2 we can say repeat step 1 for other 4 to 6 other 4 to 5 values of voltage across R. This step we can do by adjusting the size of the variable resistor. Okay, along with that, here repeating the step, measuring currents and averaging it for each value of voltage. Now as step 3, since here they are not talking about the graph, we are not writing that. If they mention about drawing a graph, means you can say that plot a graph of I versus V. But here in these type of questions, investigation question, you must include one safety measurement or safety precaution. So as a safety we can say switch off the circuit, I'm writing CKT. CKT means it is circuit. Switch off the circuit in between so when you switch off there is no current flow in between readings to avoid overheating of the wires. Now let's see the next part of the question. Complete the current voltage graph by drawing a line that shows the expected results of this investigation. So let's see what is expected from this. See, as we see here, it's a 60 ohm resistor and the battery is, here you can write it as 12 volt battery, 12 volt battery. So 12 volt battery and 60 ohm resistor. Therefore, we can write what is the, or we can calculate how much current is expected from this one. So how much current is expected from this? So let us see that. See the expected result. Okay, so expected result is for a maximum 12 volt. The expected current, let us see. So expected I max, current maximum. It is the voltage over resistor. That means it is 12 volt over the resistance of 60. So this will give 0.2 ampere. This is the expected current. So when you are drawing the graph, the maximum value of current should be zero point 0.2. So let us mark that one. So for 12 volt, we have 12 volt here, 12 volt and zero point 0.2. So this is the maximum current. Now since it is a resistor, fixed resistor, we know that it is an ohmic component. The current and voltage are directly proportional. Therefore, it should be a straight line. Since it is directly proportional, it should pass through the origin also. So draw slowly with your ruler. From 0, join it to the point. So this graph is for R equals 60 ohms. This is the expected graph. And this is very important, the step, okay, 0.2 amps. This is for 60 ohms. Now, the student repeats their investigation with the 120 ohm resistor. Explain how the current voltage graph for a 120 ohm resistor compares with the previous graph. So previously it was for 60 ohm. Now it is for 120. So let us see what is the expected current for Imax. Imax is voltage over resistor, that is 12 over 120 ohm, which is 0.1 ampere. So this is the maximum current for. So let us mark that one here. For the next graph, 0.1 is this point. Okay, so it is 0.1 ampere for 120 ohm resistor. And again, you know that 120 is also a fixed resistor. It's an ohmic component. Therefore, it should be a straight line. The graph should be a straight line, and current voltage relationship is directly proportional. So it should pass through the origin. So let us complete the diagram for the second one. It should pass through the origin, and it should end up at 0.1. Okay, please use your ruler to draw a straight line graph. So it should be here. So this is for R equals 120 ohm resistor, straight line graphs. But here they are asking, explain how the graph compares with the current voltage graph for the 60 ohm resistor. So we can see that, or we can say that the line should pass through the origin. Okay, the line passes through the origin. Origin for both 60 ohm and 120 ohm, as they are fixed resistors. Fixed resistors. They are fixed resistor. So V directly proportional to, or I directly proportional to V. This is first one. Second one is both should be a straight line. Okay. Both graphs should be straight lines. Be proportional to I. Fixed resistor, this I can write it as V and I are directly proportional. V and I are directly proportional. Now, the next part of the question is, a student investigates how the current in a filament lamp varies with the voltage. So there is a filament lamp. Then draw a circuit diagram that the student could use for this investigation. So there is a filament lamp. We need a filament lamp. Then we need a cell. There must be a variable resistor, an ammeter, voltmeter, and of course the connecting wires. Draw the circuit diagram. So when we draw the circuit diagram, let us draw the cell first, then an ammeter to measure the current, and here then there is a variable resistor. And also let us include the voltmeter to measure the voltage. This is the lamp, filament lamp. Then the next part of the question is data is provided, plot the results on the grid and draw the curve of best fit. So here I have copied the data again just to save time. So the data, voltage and current it is given, and also here the current and voltage axis with the scale it is provided in steps of 1 on voltage axis and in steps of 0.2 on y axis. So let us start marking the values. Before that, to make the things easy, better you find a proper scale to enter the values. As an example, this is for y-axis. Let us go to the y-axis. Y-axis 0 to 0.2. That means there are 10 divisions here. These 10 divisions are 10 divisions corresponds to 0.2 ampere. So 0.2 ampere is 10 divisions. Therefore, one division is 0.2 over 10, 0.02. So when you are entering the values on the y-axis, each division is 0.02. Okay, so let us mark the first one, 1 volt, 0.38. So 1 volt, so 1 volt on the y-axis, x-axis. So here is 1 volt and 0.3. This is 0.3. Let me write that also, 0.3. This is 0.1, 0.5, 0.7 and 0.9. Now first one is for 1.38. This is 1 here and 0.38 is after 3. Remember each small division is 0.02. 3, 3.02, 04, 06, 08. So it is 3.8 is coming here, 3.8. Now the next one is 2 and 6 1. 2 and 6, where is 6? 6 is here, it will come somewhere here. 3 and 0.8, 3 and 0.8, then 4 and 0.9, 4 and 0.9, it will come here. Then 6 and 1, 6, 5 and 0.96, 5 and 0.96, it is here. And 7 and 1, 7 is 6 and 1, so 6 and 1 it is here. Now join it. So for 1 volt it is 0.38. Okay, now join them as a straight line. Not straight line, I mean connecting the points, passing through all the points. So we are getting a line like this. So you can join it with the axis also. So it is in this way. So this is the first point, the second point, third point, fourth point, and so on, and the last point. Now the question is, the filament of the lamp is made of metal. The student suggests that a straight line on the graph is more appropriate than a curve because current is directly proportional to voltage for metal. Suggest how the student could improve their investigation to find out whether a straight line or a curve. Only one thing we can do here, take more data for or take more data at different voltages. Take more data. At different. Now explain why the student should not expect current to be proportional to voltage for this filament lamp. Okay. So here, if we have seen that if it is an ohmic resistor, the current and voltage are directly proportional. That means a straight line graph is expected. Students should not expect current to be proportional to the voltage. You know, as current passes through the filament lamp or current passes through the filament, there is a wire. That wire gets heated. Temperature increases. Wire gets heated means the temperature increases. So the resistance of the wire increases. Therefore, the current decreases for the same voltage. Therefore, you cannot expect a straight line graph. So let us put it as an answer. Current heats up the filament as current passes. Current heats up the filament. Current heats up the filament. So temperature, I'm using the symbol increase. Temperature increases and resistance also increases because the filament is made out of a metal. For a metal, resistance increases with the temperature. R and T are directly proportional. So when the current passes, the temperature increases, accordingly the resistance increases. So current decreases for the same voltage. Current decreases for the same voltage. So directly proportional means as the current increases, the voltage also should increase. But here the current decreases for the same voltage. The next part of the question is, there are two loudspeakers connected in series. Show that the total power of the two speakers is about 0.1 watts. It says that the total voltage across the loudspeaker. So this is the total voltage, V total, and the current is 0.15 ampere. Show that the power of the two speakers is 0.1, and you can use the equation power is the product of current and voltage. So the total power is current times the total voltage, which is 0.15 times 0.75. Please make use of your calculator. This will give an answer of 0.1125, approximately 0.1 watts. 0.1 watts, the expected answer. You can write even it as 0. The expected answer is 0.1 watts. The next one is a set of data provided. Again, it's a graph, set of values of resistance and the corresponding power calculated. Plot the graph and draw the line of best fit. Mark the points. And here, it's not specifically telling that which is the x-axis or which is the y-axis. So it's our choice. So I'm going to take resistance on the x-axis. So let me mark it here. I'm going to mark resistance. It is resistance in ohms, resistance on the x-axis. And the other one, power in watts on y-axis. The power is on y-axis. So this is the y-axis. I'm marking power here. Power in watts. So this is the y-axis. Now also let us make a scale for this one, and I have already marked or I have already copied the data again here, and it's difficult to mark 3 decimal places, so I round it to 2 decimal places, or I can say 2 significant figures. So 1.100, it is 10, so I have already reduced it to 2 significant figures. Now, what is a convenient scale we can use here? The x-axis is varying from 0 to 15. So maybe we can put it as 2.5. This first one is 2.5. Then 3, 6, 9, 12, and the last number is 15. Y-axis we can take in steps of 0.01. So 0.01, each box is 0.01 because it is changing from point up to 0.11, but the smallest number is 0.09. 0.09. So let me take each one as 0.01, 0.02, then this is 0.04, this is 0.06, 0.08, 0.09, 0.1, and the next one is 0.1, 0.2, 0.2. Now here again I have chosen a scale of y-axis in such a way that there are 10 divisions till 0.2. 0 to 0 to 0.2, you can see there are 10 divisions, therefore one division is 0.002. So let me write this also. The next values in between, it is 0.03, then 0.04, and this is I think this is 5, 6, and this is 0.078, it is 9. Is it correct? 1, 2, 3, 4, 5, 6, 7, 8. Oh, this is 0.9, 1, 0.1, and then 0.2. Okay, 1 point, the value is 0.12. Here it is 0.12. The first value is for 2.5, it is 0.1. So 2.1, 2.5, it is 0.1. Okay. Then for 5, 0.11. So I think x-axis also we have to change 2.5, 5, it is 7.5, then it is 12.5 and 15 is coming here. So this is not needed. It will be 18. This will be 18. 2.5, 5 in steps of 2.5. 2.5, 5, 7.5. Okay. So let us mark it. 5 and 0.11. 5 and 0.11. Where is 0.1? So 0.1 and it will be 0.11 here. Oh, sorry, here 0.11. 0.11 here. Then 7.5, it is again 0.11. It's somewhat 0.11 again. Then 10 and 0.1. So where is 10 comes? 10 is somewhere here. It is 0.1. 10.1, 0.1 is coming here. It's 0.1. It's 10 also. It is 10 is 0.1. Somewhere here it comes. So it is 0.1. Okay. Then it is 12.5.9. So here is 12.5, 12.5 and zero point 0.9. Then 15 and 0.08, 15 and 0.08, 0, this is 0.8, it's coming here. So let us join it. So we get a line. Joining all the points judged by your eye. So we are getting a graph like this. So x-axis is in steps of 2.5, y-axis is in terms of 0.01. Let's move on to the next question. The diagram shows the loudspeakers connected in series to a cell. Diagram 4 shows the loudspeakers connected in parallel to the same cell. Comment on how the total resistance of the loudspeakers in diagram 3 compares with the total resistance of the loudspeakers in diagram 4. We have, as you see, there is a series connection and a parallel connection. So this is the total resistance. This is series. That is the, and this is parallel. This is series and parallel. So the total resistance R total for the series connection, the R total is, we can see that the total voltage is 1.5 and current is 0.3. So resistance, it is voltage over current, which is 1.5 over 0.3, and this is giving total resistance of 5 ohms. Whereas in parallel combination, the total resistance, it is V over I, which is 1.5 over current is 1.2 amperes here, 1.2 amperes. So this gives a total resistance of 1.25 ohms. So you can see that they are asking compare the total resistance, comparing the total resistance. So when you compare 5 ohm with 1.25 ohms, you can see that here the second part is this is for parallel. This is for parallel. Okay, so I can write R total for parallel. It appears as 1/4 of R total for series. This is R total for series. 5 and 1.25. It is 5, 1.25 is 1/4 of 5. So we can see that the total resistance decreases by 4 times when it is parallel connection. And this is happening because In parallel combination, because the voltage is not shared, we know that in parallel combination, across each parallel branch, the same voltage will appear. So, because the voltage is not shared, so current is doubled. Now, the next one is add another component to the diagram to measure the voltage of component X. We don't know what is component X, but to measure the voltage, we have to connect a voltmeter. So we are connecting a voltmeter across it. Now next part of the question is, so you can write it here, the voltmeter connected parallel. Voltmeter parallel to voltmeter parallel to X. Give the name of the component X. See, the arrow shows that light is falling on the component. So this component is depending on light. So it is nothing but it is a light dependent resistor LDR. Now the next part of the question is, there is a graph given. Use the graph to determine the resistance of the component when light intensity is 4 arbitrary units. So 4 is here is 4. At 4, what is the current intensity? So use your ruler to draw the line to touch the graph, and then there you take the corresponding resistance, measure the corresponding resistance. It will come as 1700, because between 1000 and 2000 it is 1500, then 600, 700, 800, 900. So this is 1500. So this number will be 1700. So we can write the resistance as 1700. The resistance value is 1700 ohms. The current in the circuit is 0.0018 ampere. Calculate the voltage across component X at a light intensity of 4 arbitrary units. So at 4, what is the current? Current is given. Current is given. Calculate the voltage. Voltage you have to calculate uh, when across a component X at a light intensity. So we have to calculate the voltage. To calculate the voltage, we have to know what is the current and the resistance. So current is already given 0.0018 times. We have already calculated, or we have already seen that at zero point 0.4 intensity of 0.4 units, the corresponding resistance is 1700. So make use of your calculator to get the value. You have to get it as 3.06 volts. Now explain what happens to the brightness of the lamp when the component X is covered with a dark sheet of paper. So covering with a dark sheet of paper means it is blocking light, isn't it? So covering means light intensity decreases. So what is happening? So resistance of the LDR is increasing. When the resistance of the LDR increases, as a result, I decreases. Current of the circuit is decreasing. So here we have the relation resistance of the LDR and light intensity are inversely proportional. So this is the relation. So as per this relation, when the light is decreasing, the resistance increases, therefore current decreases, so the brightness decreases. So brightness decreases. Then coming to the next question, give the name of the component Y. Component Y, it is a variable resistor. Variable resistor. Give a reason why component Y is included in the circuit. So as we know, a variable resistor is used to control the voltage across the lamp or control the current in the circuit. This is to control. Or to vary the circuit current. Now the graph shows some of the students' results. The question is determine the calculate the charge transferred through the lamp in 30 seconds. Okay. State the formula linking charge, current and time. So we know that current, it is charge over time. Therefore, those who are using the triangle, you can see that charge, current and time. Therefore, charge, it is the product of current and time. Determine the current in the lamp when the voltage across the lamp is 10 volt. Determine the current in the lamp when the voltage across the lamp is 10 volt. Let us go and see. Voltage is 10. So voltage is 10 means in the graph, here is voltage 10. Voltage 10 here. Correspondingly, we are getting a current. This is the current. Use your ruler to draw the straight line and get the current. So from the graph, we are getting a current of, I think it is 0.48 because this is 0.5. So each division is 0.02. You can find out that. So if you want to know that, 5 divisions corresponds to 0.1. Therefore, 1 division is 0.1 over 5. So each one is 0.02. So first one is 4, then 0.42, 0.46, 0.48 like that. So 48 is coming here. This is the number we are getting. So let me use that value here. Determine the current in the lamp when the voltage across the lamp is 10 volt. So from the graph we are getting it is 4.8 amps. 4.8 amps. Now calculate the charge transferred through the lamp in 30 seconds when the voltage across the lamp is 10 volt and give the unit. The charge transferred. Just now we have seen the equation for charge. It is the product of, charge. It is the product of current and R. Charge, it is the product of I and T. So Q equals What is the current? We got the current as 4.8. It is again at 10 volt. 10 volt, the current is 4.8 times 30 seconds. The time is given here 30 seconds. See, here it is given the time. So 4.8 times 30, this will give 14 coulomb. So we can write the answer here, 14, and the unit is coulomb, C. Then calculate the time for the lamp for the transfer of 250 joule of energy when the voltage across the lamp is 10 volt. Calculate the time and the energy. So we have an equation for energy which is VI and T. In fact, we are getting this relation from power. Power is the rate of transfer of energy. From this we can write an equation for energy as power into T, and also we know that power is the product of current and voltage. Power is the product of current and voltage, and from this only we are getting E equals VIT. Now here we want to calculate the time. So taking time as the subject, E over V times I, and energy is 250 joules, it is given, and the voltage is 10. The corresponding current is 4.8. Make use of your calculator, and this will give time of 52 seconds. So it is 52. Now the next part of the question is the student disconnects the cell and reconnect it with its terminals reversed. Yes, he reconnects with the terminals reversed. Complete the graph to show how the current in the lamp varies with the voltage across the lamp when the cell is connected with its terminals reversed. Yes, let us go back to the graph. So here they are telling that the cell is reversed means now there is a negative voltage. So negative voltage means your graph will come in the third quadrant. Okay. So current flow is reversed when the voltage is reversed. Therefore, the graph will be in the third quadrant, and it will be the same values, but it is reversed. Both the current and voltage are reversed. So let us mark it slowly. As an example, for 4, the current is, how much is the current for 4? The current is 2 point, sorry, 0.28. It is 0.28. So 4, it is, sorry, for, yeah, it is coming here for a voltage of, so this is the number we are getting, 0.28. Then for 10, 4.8 we have already seen, so this is 10. I'm just choosing some of the numbers. 10 and 4.48, 0.48 is coming here for 10. So this is the point we are getting. And of course the last one, don't miss the last one, it is 12 and 0.5. So here is 12 and 0.8 is point, not 0.8, 12 and 0.5, 12 and 0.5. So this is 0.5. For 12 volt, the current is 0.5. So this is the point I'm getting. Okay. So I'm joining. I can take even one more between 4 and 8. Say this is at this point between 4 and 8. That is this point. What is the current giving here? The current is 0.3, 0.38. 0.38. 0.38 is somewhere here. So now I am joining slowly. Slowly I am joining them. passing through all the points. Okay, this is the shape of the graph coming. Then let us come to the next question. The students remove the ammeter and voltmeter from the circuit. The student replaces the filament lamp with a light emitting diode. So this is the light emitting diode LED. Arrow shows that it is emitting light. The question is, explain why the LED flashes on and off. It replaces the lamp with the LED and it replaces the cell with an alternating current source. That is the reason. Cell, which is DC, and this is an alternating source. So we have studied about DC. DC means flows in one direction. Flows in one direction only. But what about AC? AC varies continuously. Varies continuously. Okay, so here it is, an AC is used, and also LED has a property of LED can uh, make the current flow only in one direction. But we have a variable source that is like AC. The AC is changing its direction. So let us put it an answer. The AC is changing its direction, but LED allows current flow only in one direction. AC current, AC or the alternating current, alternating current source changes direction, but LED allows current in one direction only. So LED will not light up when the current flows in the opposite direction. So LED will not light up current flows in the opposite direction. Now let's start with the next question. Question number 24. There is a light emitting diode and a resistor in series with a cell and an ammeter. As you see, this is a symbol for the light emitting diode. It is emitting light. And there is a fixed resistor, 95 ohms. So let me write it as resistor R. The question is, the voltage across the LED is 6.63. So let us write the voltage across the LED, that is V of LED, voltage of the LED, which is 0.63 volts. Now calculate the current in the circuit. This is what they are asking. So we know that from the cell of 1.5 a current is starting. Since LED and resistor R are connected in series, the same current I is flowing through the resistor also. So the current flow through the resistor, it is the same current. Let us call it as IR. It is the same. IR and I, it is the same only. Now here, to find out the to find out the current of the circuit, usually we are using the total voltage over total resistance. But here you can see, we don't know what is the total resistance. We know only one resistor, 95 ohms. So that method we cannot use. So usually we use the relation I is equal to V over R total. But here we cannot use this because we don't know what is the R total. We know only the resistance of the fixed resistor, but we can calculate what is the voltage of the resistor. So from that we can calculate the current flow through the resistor, which is same as the current flow, the circuit current I. So since these two are connected in series, we can say voltage of the cell, which is voltage of the LED, plus voltage of the resistor. From this we can write the voltage of the resistor is voltage of the cell minus the voltage of the LED. So let us use that value here to calculate the current. So here it is also equal to 1.5 minus 0.63. So let me use that equation to find out the current through the resistor. It is voltage of the resistor over its resistance value. And voltage of the resistor, we are getting it as 1.5 minus 0.63 over the resistance value, which is 95 ohms. Now this number on calculation, it is coming as 0.00915 amperes. But the question is they want the answer in milliamps. So to convert this number to milliamps, we have to multiply this with the 1000, that is 10 to the power of 3. This is on calculation, it is giving an answer of 9.15 milliamps, which is approximately 9.2 milliamps. So we see that this is the current flow through the resistor, which is same as the current flow through the, see, this is the current flow through the resistor, which is same as the current flow through the circuit, the main circuit current, 9.2 milliampere. Now the next part of the question is, as you see, they added one more branch. This is the first branch with the single resistor. So this is the first branch with a single 95 ohm resistor and a single LED. This is that resistor, and then there is an identical resistor and LED are connected as the second branch. So this is the second branch. So here you can see there are two branches, two parallel branches. And we can calculate what is the total resistance of each branch. They are identical, no? Because identical LEDs and the resistors are used, therefore the total resistance of both of them will be the same only. Now let us calculate in such a way that let us compare and see. It is a one branch circuit. The first one is a one branch circuit and the next one is two branches. So let us separate it into, first one is one branch, the next one two branches, two branches. Let's see what is the total resistance of one branch, which is the resistance, fixed resistor plus the resistance of the total resistance is fixed resistor plus the resistance of the LED, but we don't know how much is the resistance of the LED. Okay, R plus R of LED. This is the meaning of total resistance. But we don't know how much is the total resistance, or because we don't know what is the resistance value of the LED, but we can calculate the total resistance as the total voltage, that is the cell voltage over the total circuit current, which is 1.5 over 9.2 times 10 to the power of negative 3, this much amperes. On calculation, this is giving an answer of 163.04. So I'm writing it here, 163.04 ohms. This is the resistance with the one branch. So let me write it as RT with the one branch, the total resistance, RT one branch. With the one branch, this is the resistance I'm getting. Now let's see how much is the total resistance, and actually also we can calculate the current for one branch. There is no need of calculation because we already calculated it is 9.2 times 10 to the power of negative 3 milliamps. We already calculated, okay, calculated in part B. Part A calculated in, see the first part, I mean here, A calculated in A. Calculated in part A. A part of the question we calculated this already. But let us see how much is the total resistance when they are connected parallel. Two branches parallel. And as we see here, each branch is having a total resistance of RT. This we already calculated now. It is 163.04. This is the total resistance. This is also 163.04 ohms. This is the total resistance of each branch. And the total resistance of parallel connection, we studied it as, it is 1 over 1 over R total. It is 1 over RT because each one is 1 over RT. It is a sum of the reciprocal of the individual ones. So on calculation, substitution and calculation, 163.04 plus 1 over 163.04. This is on calculation. It will give you a value of RT as 81.52. 81.52 ohms. This is the value we are getting on calculation. But we can see that this 81.52, it is half of 163.04. So this is, let me write it as, this is RT of two branches. This is RT of two branches. With RT two branches, this is the value, which is same as RT of one branch over 2. Let us compare and see. RT of one branch is this number, this value, and the RT of the second one is this one. So let us have a comparison between these two. This is half only. So since resistance is, so here you can see the resistance is halved. So as a conclusion we can say that is resistance is halved. I mean RT. Let me write it as total resistance. RT is halved. This is the conclusion we are getting from here. So current will be doubled. That is I equals, current is doubled means with the one branch, 2 times current of one branch. Current of one branch circuit. So which is 2 times one branch current is, this is with one branch. Again this is with one branch. 9.2 times 10 to the power of negative 3, which is 18.4 into 10 to the power of negative 3 milliamps.